So, good afternoon. I'm Daria Lichtenegger. I work in the European Environment Agency, and I will present a joint presentation about the reporting data flow that provides the European data collection of nationally designated areas. So first, briefly, what is European data collection? You will recognize this is a collection under another name, and this is Common Database on Designated Areas. So CDDA is the old name, and we still keep the acronym because it is already well established. So this is the same, we are talking about the same thing. It's not a new reporting obligation. But this data collection is actually very important, and it is the European inventory of the protected areas that are established under the national legal instruments, and it is used for the assessment of the European environmental policies, and also it is provided as an official source of European information to the whole database of protected areas. The collection started in 1995, and it is one of the core data flows within the European Environment Agency and the IONET network, and at the same time is included also in the list of the priority data sets for the e-reporting for the European Union environmental policies. And this priority data set, this list of priority data sets is now within the development of implementation within the INSPIRE. So this is an annual collection of data, and the last reporting cycle already in 2018 has been already concluded. Over the years, the data collection has been increasing and has been expanding as well to include more reported countries, to provide more complete and precise information, to improve quality of data, and also to reduce certain gaps, like, for example, the gap between the provided spatial data and the non-spatial data. And today, the data collection includes more than 110,000 information about more than 110,000, how did I say? 110,000, yeah. Different protected areas with information of their size, types, when they were established, and a lot of other information. So one of the information that we found analyzing the outcomes of this reporting cycle is that we have increase of more than 5,000 new designated areas, but also the increase of new spatial data. So more than 7,000 spatial data were reported in this reporting cycle. We also noticed the improved gap between the spatial data and non-spatial data. So this matching is now close, and one of the reasons that we achieve better matching between these two types of data is the introduction of a more strict quality control rules that accepted only those data deliveries that really provided both types of data. Over the years, this data model got some upgrades, some changes, and now it was the time, and also included some new information that were coming from the environmental policy, so it was time actually to look at it and to decide for the modernization. And the main requirements for this was to first exclude some outdated and redundant information, also to improve data quality, but also to ensure that despite modifications, all the reporting countries, which are going beyond the European Union member states, will be able to provide the data. This was also the opportunity to look into the INSPIRE implementation and find a way how the INSPIRE data, how the spatial data provided according to the INSPIRE implementation can be included in this data flow. And the modification actually impacted the complete reporting process. So if we start with the data model itself, the redesign of the data model required first to optimize the old data model, to find a way how to include the INSPIRE data specifications, but also to ensure the transformation between the old and the new data model. In addition, it was necessary to develop new guidelines, new tools, templates, and set up appropriate help desk that was very active in the preparation phase for the reporting, but also during the reporting period, providing a lot of technical and thematic support. And let's say the third part of these changes affected the data quality procedures, because the EA introduced new quality controls at the point of data delivery, which detected early in this process potential errors, but also provided some tools and notifications and feedback to data reporters to correct the data with errors. So now let's look how Inspire was actually included in this reporting data flow. So starting from the scope point of view, the nationally designated areas, the scope of these nationally designated areas is related to the scope of the Inspire protected sites, and the semantic mapping shows that there is already some certain overlap of information between both requirements. However, the Inspire protected sites application schema or data model was included as it is defined in the Inspire specifications, so there were no changes, no extensions. And in addition to this, the specific thematic information that are requested by the nationally designated areas are provided in another thematic-oriented scheme. What is important here is to establish the linking mechanism, which allows that each designated area was referenced to the special objects that were provided through the Inspire implementation. The encoding level was GML for spatial data, Inspire spatial data, and the XML for the, let's say, for the business data or type 2 data that included the specific thematic information. The data delivery itself still uses the ReportNet platform, where the central data repository provides actually a secure and controlled environment where the data can be provided, uploaded, and this repository includes also additional tools that helps to assure certain quality of data that are reported. So there are tools conversion tools, quality control tools, notifications, everything that can help data reporters to really provide data in the way that this can be technically accepted with certain level of quality. Now let's look into the linked approach. So this is the most important part to assure that you can combine, let's say, thematic data with the spatial data that are provided according to Inspire specifications, and this link is designed at 2 levels. The first one is dataset link, which actually allows that you have references to the correct data sources which provide spatial data. And we implemented this in the current reporting cycle just as providing the names of the GML files. However, in the future, this could be also replaced with the service endpoints. So we can go more directly into access to the data through the Inspire services. The second level of the linking is at the object level, which is important that each designated area description can be properly matched to the corresponding special object inside the special data set. And this is achieved by referencing the external object identifier, which means that in Inspire, this is the Inspire identifier. So this was used at the object level. And here on screen, you can see on the left side, type 1 data present the Inspire application schema, simple application schema, just the main, the core element, the core feature type. And type 2 data present the attributes, the characteristics of the designated areas, which is provided then as another thematic-oriented schema. A little bit for statistics of how this was actually reported. So far, 33 countries reported, and we achieved very high level of the technically accepted data deliveries. Only a few countries couldn't find the right way how to report the data. And I think that with this new approach, this was quite a good success. Another look we had another look also into how the data sets were reported, and we noticed that thematic data were quite easily reported, let's say the complete national coverage in one data set, where there was quite several cases where the spatial data were provided in several data sets, and there are many reasons for this. One of them is maybe that 2 different types of geometry were provided, like polygon and points, or that there are several responsible authorities who can provide this spatial data, or that there is maybe different coordinates reference systems, like, for instance, designated areas in European countries' overseas territories. So there are several reasons that there were several different spatial data sets. Briefly, our conclusions. We were very happy with this reporting. We saw that there were no big issues in providing, let's say, inspired spatial data in GML encoding. And this was also provided through the conversion tools or directly provided by the data reporters. Also, the linking mechanism, which is the important key element in this approach, was provided successfully, and it was implemented on both levels, object level and dataset level. And the quality control that was implemented provided really ensured that we got much better quality of data at this point. But I have to mention also the last point. So all of this, I think that one of the main drivers to have a successful delivery, to successfully implement all the changes and have a delivery, was a very active help desk, which was available to very individual discussions about the technical and the thematic issues, and was really ready to help to overcome all these obstacles. And this was quite a lot of work to provide this in the preparatory work, but also during the reporting process. So, thank you very much.
Thank you, Gaia, for the presentation. Very clear, I think. Time for a few questions. The microphone doesn't seem to work, but since there are not so many, I think we can do it up. We start with Wim, and we've got 3 questions for you guys.
Okay.
Thank you, Gaia, for the presentation. My name is Wim van der Maas from the Netherlands. There is a very cute one.
I'll try another one.
Thank you. My name is Wim van der Maas from the Netherlands. Thank you for the clear presentation. And I think you did a great job in helping the member states to make it as easy as possible to do the transition. I recognize the principle from also other e-reporting obligations, but I want to ask a very fundamental question. What is the basic driver not to include the thematic information into the inspired data model?
Yeah. Yes, thank you for the question. We were asking this question at the beginning as well, because the EA in the past made other attempts to maybe make extended inspire model and harmonize this data in that way. But there were several reasons to use this approach. One, it is that there are countries who report to CDDA that are not ready or they are not obliged to implement Inspire, and this might be difficult for them to use this approach. The second one was that we were relying on current Inspire implementation because we know the protected sites in Annex 1 should already be provided. So for us, this was just the reuse of the available data because we didn't change anything what Inspire defines. And in this way, we actually shorten a little bit, I think, the time that to require another special data in another way.
Okay. My name is Andre. I wanted to ask you one thing related to the reporting process. If I understand it properly, the member states could upload their file within the ReportNet IONET infrastructure. Do you think in the future to do harvesting of these datasets?
Thank you for the question. It's actually a very timely question because I have to say that there are currently coordinated activities between the European Environment Agency and Commission and member countries to look to modernize ReportNet and to look also how to use the services for data harvesting. So there are some studies ongoing and requirements will be collected to guide then this future ReportNet implementation.
Yeah, my name is Dirk Hinterlang. I was in the thematic working group of protected sites, so I know very well about all the data model and the thoughts behind it. And by the way, I was a facilitator of the biodiversity themes with the thematic working groups. The things that you told here today are just the same that you told us last year in the last Inspire conference. Now it's implemented, yes. Yeah, now it's implemented. And you ignored that the audience last year had serious concerns which went towards the same question that our colleague from the Netherlands has. Namely, protected sites was meant to include thematic data from the very beginning. If you go back to the specification, you can read that there should have been a CDDA extension to the data model of protected sites from the very beginning. There was an extension for Natura 2000 data. It was taken out for several reasons, but there are no good reasons not to put them in again. What you now installed and implemented is a parallel way of reporting data. And I want to repeat some of the serious concerns that we have with this approach. For example, those thematic data, what you call business data, type 2 data, or whatever you call them, they are reported to the ReportNet. So they are not on Inspire. And they should, because they belong to the geometries that create the protected sites. And there are no legal obligations for the member states to provide these business data, type 2 data, but there are legal obligations, namely the Inspire directive, that they have to deliver the protected sites data. So it would be very clever to model those extensions, that's what I see as an extension, under the protected sites data specification. And then it would be a fine approach. But this way, it's not acceptable.
I'm not sure we have the time to discuss your concerns here, because we have a lot of other presentations, but do you want to start?
Yeah, so thank you for your view. I really appreciate different views. So the CDDA reporting is the agreed reporting between inside the IONET network and goes also beyond IONET to other European countries. So even so that there is no strict legislation behind, this agreement provides and shows that this data collection already has a long history of, let's say, more than 20 years. So I hope this will continue. One of the I agree there, maybe we are speaking here about two approaches, Inspire extensions or maybe a linked approach. Which one is better is now difficult to evaluate. We found this very practical to implement. And we are really reusing what is already there as Inspire, implemented as Inspire part. And I think this from Inspire implementation point of view might be a good start that we start using Inspire data and maybe from the usage point of view provide some feedback, which can then lead maybe to the decisions, do we need better harmonized extended data model or maybe some other ways. So this would be more my personal view. And I think that how it was implemented was very well accepted by the countries, but of course there could be maybe some other concerns like you said as well. I would just like to point out that all the work that is needed to harmonize data models, and here we are talking between two obligations, Inspire is one, and let's say CDDA is the other one, requires a lot of work, long discussions, big working groups, consultations, and that's something to consider in every reporting obligation data flow, in every. So let's say that this, if we see that Inspire development of data models, the old specifications was maybe 2 years, and this data harmonization will again be at least 1 year. Maybe some other changes will come so fast in that is on the thematic side, not that much on spatial data side. On the thematic side we might be in a loop to all the time changing the thematic site area, no? And with this approach, this is easier to do. I think this is easier to do.
I think we have to leave it with that, unfortunately. We have a little bit more time because one presenter seems to be missing, but I want to give also the fair share to the other people. So if you want to stick on and we can later discuss this, or you can discuss it with Daria, myself, a little bit aside the meeting. We're happy to offer that. But I think, as Daria says, this is a pragmatic solution. I think it doesn't forbid you to provide everything in one file, by the way. Yeah. It's just the option for those many who want to do it like this. So with this, let's pass on. Thank you very much, Daria.
Thank you.
We move.
So, there it is, okay. So first, and before I start, let me just say to you that I am a last-minute replacement, so I am here substituting a colleague of mine. So I hope that I will be able to deliver the message in this presentation well enough. We are presenting a small project called Inspecting using Copernicus and UAV Data. And this project is led by the General Inspectorate for the Ministries of Environment, Spatial Planning, Agriculture and Sea, the place where I work for. I am a GIS analyst and a developer. And it is funded and framed within the European Union Network for the Implementation and Enforcement of Environmental Law. It has this acronym, and it relates mainly with satellites and drones. So this project started because we actually had questions and needed help. We were just starting to use this technology, mainly in our case drones, in some of our partners satellite imagery, and we had several questions we wanted to ask. Who are the users of these two technologies? How are the Copernicus services used as tools in environmental inspections? How are UAVs being used as tools in environmental inspections? And finally, was the data collected through these two technologies used as evidence in court? And this is the question because every time we prepared anything regarding these technologies, our colleagues of inspectors always asked us, okay, so we have this and this shows us this situation. If I take this to court with me, will it prove as evidence? So how did we proceed? Well, we tried to identify other users of this data, mainly in other Portuguese public entities, and tried to identify what were the best practices and methods and knowledges that were gathered between all these entities. And then we tried to widen the search a little bit further, and that's why we presented a project to the Impel network, who we are a part of. So what is Impel? Impel is an international nonprofit association of environmental authorities, and since it has 53 members from 36 countries, it seemed like a good place to start. We had a good audience for that. And so, oh, sorry, wrong slide. So this is the project timeline. It's been ongoing in this year, in 2018, has all these events. And so we started by turning in our questions into a more suitable mean of dissemination, a questionnaire. So we sent this questionnaire to all our members of the Impel network, mainly asking them if they were using these technologies, how were they using them, and if they were using both, if they felt the need for training or not. And so these are some of the results. Regarding Copernicus, there are a lot of, about 50-50. Some of them are already using it for image interpretation and analysis, and half of them do not have any experience at all. Regarding UAVs, experience is a little bit wider, but mainly on an area of photographs and videos, not in related products such as orthomosaics or digital surface models or digital terrain models. Come to the use as evidence of these products in court. Mainly, most of them don't have an answer for this. They don't use them. And some of them said this is still in development a bit. The knowledge is unconsolidated. So this answer seemed to be unanimous. Which field of activity could be more relevant? So we have environmental inspections as a whole. And based on the answers from the questionnaire, we assembled a project team, mainly because we chose the ones with more experience relating to these two technologies. And we have a partner from Spain, 2 partners from the Netherlands, 1 from Italy and 1 from Ireland. And so we organized a kickoff meeting where everyone could present their work and their experience regarding these technologies. And I'm bringing you some of the products that were shown. I cannot bring them all because they are pending the end of the project, so I didn't have the permission to bring them all. These are some of our own experiences using UAVs. So this is an orthomosaic made by one of our drones, the digital terrain model, the digital surface model, and here is a test we made on a 3D model of a landfill, where we can calculate areas and volumes, and this seems to be very useful in monitoring the level of amount of waste deposed or extracted. Here are the contour lines, 1 meter apart. And here are some experiences using a thermal camera. This is thermic data. We can evaluate the temperature of several points highlighted in the image. And this is an example of a water discharge in the river. And so the project is now pending towards a workshop we are hosting in Lisbon. And since we had a whole lot of interest in trying to understand and get training in these two technologies, we are hosting a training session on satellite data acquisition and processing, and then a second day where we are sharing the knowledge of everyone that participated in this project to other countries so they can learn and share with us some of their questions and concerns. And so, back to the beginning, some of our possible answers so far. So, are Copernicus services used as tools? Yes, they are. Mainly in pre-analysis and planning of inspections and monitoring detect land use changes. As to drones, they are being used, monitor and detect land use changes also, monitoring waste areas volumes on site and water discharges. However, we are still struggling a bit with computation because it's still limited when we are dealing with large amounts of data, which has been the case. Related to the use of these two technologies as evidence in court, where right now we are still unsure because most of our participant countries have not yet used this collected data as evidence, neither have we, but we are proceeding for the first reports using them, so maybe we will have some answers soon enough. And this is what I brought for you. Thank you. If you have any questions.
Thanks, Claudia. Great pioneering work.
We have a national Copernicus forum in Germany, which is a big forum once a year where where a lot of people come together and exchange their experience with using Copernicus data in the wider sense. That is not only satellite data, but also UAV data of several sensors. So I was a little bit surprised to see that you first had a questionnaire all over Europe asking who is working in this field, because I don't know why I thought that Copernicus forums will be held in all member states, because the ESA is interested in providing this the information about the Copernicus project, of course, in a wide extent. So this could be a possibility to exchange more knowledge about projects in different countries, at least in Germany.
Okay, thank you. I do believe there are several occasions where this exchange of information is done. Actually, this was a little bit, maybe it was, maybe I didn't explain it well. It was a little bit enclosed inside the Impel network, so maybe that's why the questionnaire didn't reach as far as it should have been. Maybe that's a step that we can take further if this continues on 2019. So thank you.
Yeah, I think from my observation also, it's not, Impel Network is not the usual visiting community to Copernicus events. Huh? I mean, that is still a new link which has to be made on the governance level, if you want to. Any other question?
So, and it is on the big screen as well. Good afternoon. So my name is Hugo Poelman. I'm working for DG Regional and Urban Policy of the European Commission, where I'm responsible for the team dealing with geographic information and geographic analysis. So this presentation intends to inform you about the state of play of an analysis project we are managing on developing a system of accessibility and sustainable mobility indicators for European cities. Obviously, sustainable development in cities poses substantial challenges to issues of urban mobility. And both at the European scale and at the global scale, this challenge is translated in high-level political goals in the Sustainable Development Goals, for example, and the related indicators, strategies and actions as included, for example, in the projects related to the EU Urban Agenda, and also in the implementation and the conception of cohesion policy. We see over the periods and over the years an increasing focus upon the promotion of sustainable development of cities. But to underpin these policies, there's a clear need to be able to assess situations and trends on the ground by means of harmonized indicators at relevant territorial levels. So speaking about these territorial levels, what is crucial here is that we compare what is comparable in a spatial way. Now, assessing accessibility and mobility requires people-based concepts because both accessibility and mobility are clearly related to services provided to population in urban areas. So for that reason, what we will use in this project is a grid-based concept of urban centers. It's a concept of cities or urban centers, if you, as we know it, being clusters of grid cells, of densely populated grid cells with an accumulated minimum population of 50,000. And so this is a European definition that is now also being promoted for an extended global use. And the result, these urban centers, if you compare them to the traditional administrative definitions of cities, they can be similar, like here in Brussels. They can be larger in the case of Dublin, for example, or much smaller in the case of Malmö, for example. Now, going to urban accessibility, let's first have a look at the case of public transport. As accessibility to population is clearly impacted by numerous factors like the availability of the transport services, their performance in terms of speed and frequency, but also by the spatial population distribution and the concentration of its population in the urban centers, and by the road network layout, it's obvious that a single indicator saying something about public transport and accessibility will never tell the whole story. So for that reason, we have tried to develop a set of core indicators that each of them inform about a particular aspect of the availability of the services and the related accessibility. So first we can look into the distribution, the availability of public transport stops, and express this per capita, or also quantify the number of departures per capita. But by doing so, what we ignore completely is the spatial distribution of population. So in itself, it's obvious that the availability of the stops and the departures, it's a minimum requirement, but it's not enough to tell something about the relevance of the services in the urban areas. So next, we will combine this information with the distribution of population by assessing which part of the population has an easy walking access to the departing services at the stops nearby. We can, for example, compute the share of population that has no services at all at walking distance, that lives just a bit too far from any stop, or also the share of population that has a very good, finds a very high or high frequency of services in their neighborhood. Okay, that's all very fine in order to inform about the availability of the services in your neighborhood. What is still lacking is in how far these services bring you somewhere where you want to be. So accessibility, and here we will focus on accessibility to residential population. We have assessed it by running origin-destination calculations from each populated building block to each other building block in the same urban center. And then counting simply the population that can be reached within 30 minutes. We've done it also for 45 minutes. The choice is a bit, well, it's not arbitrary, but it is appropriate for certain sizes of cities. And the accessibility, that is the travel time that is underpinning this calculation, combines public transport with walking if walking is required, because nobody will, or seldomly, you will find a public transport stop next to your door, so you will first walk to the stop. That time is taken into account, and then we take into account the frequency and the speed of the services to get this result. This is still a result in terms of absolute number of population. It's interesting, but it still needs some more interpretation, because it's also dependent on the spatial distribution of population. If we want to isolate the performance of the public transport services from the spatial distribution of population, then we went to this indicator where we express the accessibility of the previous slide relative to the neighboring population by having first computed the population you can find in a radius of 7.5 kilometers, which corresponds roughly to an average speed of 15 kilometers per hour, which from the observed timetable data is a reasonable average for public transport in an urban environment. We've done something similar for the active modes, for walking and cycling. For walking, we took the ratio of population within 30 minutes walking to the population in 2.5 kilometers radius. And so the differences observed here indicate some elements of the walkability of the network. If your building blocks are large, you've got less opportunities for an efficient and fast walking to your destination. You might also encounter obstacles like urban motorways and so on. And so these are taken into account when computing this indicator. Same logic for cycling. There we took also this implicit average speed of 15 kilometers per hour. There the data issues are a bit more problematic in a sense that it's quite hard to get adequate info on the characteristics of the street network in terms of their appropriate characteristics for cycling, be it on the physical elements, the comfort or the road surfaces, or the legal aspects. For example, a typical case is it allowed to drive to ride your bike in the opposite direction in one-way streets. This is not something you readily find in commercial street network data sets like TomTom or so. And it's also something where with open data like in OpenStreetMap network, that you cannot basically know in how far this information is complete or reliable. Now, we've seen a lot of maps here at the level of the individual building blocks. We also need to digest this and to aggregate at the level of the urban centers. By the way, on the map you see for which cities we have done this analysis. There are not so many. It's a combination of issues of data availability and also computational burden. All aggregates by city level are population weighted, which means that we take into account the population of the starting point of the trips to weight all the averages. Once computed, this allows comparisons between cities, but also between modes. And apart from the indicators we have computed, we have added a few more, like the population size of the city definitely is an important factor. The weighted population density measured at 1 square kilometer grid cells, which informs about the concentration of the population inside your city, and also the median building block size, that is a factor of walkability or ease of cycling. This will yield a few, we will still experiment a bit more with other ways of visualizing the information, but you can expect kind of graphical tools of comparing the summary indicators, and it will result in profiles per city that can be quite easily compared. Now, some challenges remain. I think slowly we are getting at a methodology that is that can be used throughout various cities and environments, provided that they're open, timely, and harmonized data. This requires comprehensive public transport timetables and the location of the stops, also an adequate street network and the attributes, detailed information about population distribution, preferably also about employment distribution. That would allow us to also say something about accessibility to daytime population, not only residential population. And moreover, the access to services location would also be an interesting element to explore. But then we are running into issues about the definition of these services and the implementation of data related on their location. And land use and building characteristics, here we come more closely in the field of Copernicus and Inspire. They're very important and very interesting in this field, not for the sake of the building itself, but because it is important auxiliary information to downscale the population and the employment information down to a high spatial resolution, where otherwise from published sources you can hardly get the information. Moreover, adequate computing resources are needed. We have run a lot of these computations in a cloud environment, but despite this, it requires massive origin-destination calculation amounts, and it's quite some obstacle. But there are also opportunities, yeah, fortunately. The development of a global people-based city concept opens opportunities to apply this kind of indicator frameworks, not only in a European context, but also elsewhere. Now, the ongoing Inspire implementation, more specifically on population distribution, building units, and transport networks, will ease the obstacles of data provision. The same applies for an initiative of DG Transport and Mobility on multimodal travel information services, where in the next years, the national access points will see the light, which are intended to provide comprehensive data on network characteristics and public transport timetables, also in an Inspire-compliant way. And moreover, the Copernicus land component services like Urban Atlas, imperviousness, and the related settlement layer informing about built-up areas are also important assets for the further development of this kind of indicator network. So what's next? In the near future, we will discuss this with other specialists in a workshop on urban accessibility at the European Week of Regions and Cities in October in Brussels. In parallel to our work, the International Transport Forum, related to the OECD, is doing some exploratory work on cities and functional urban areas at a slightly different geographical scale, but in the same logic. This will result in an ITF OECD web publication. And the whole project will also be a proposed discussion topic at the ITF summit next spring that will be dedicated to regional connectivity. Happy to take any questions now or later, and you can find a few additional sources of information if you go to these links. Thanks.
Very interesting analytical work you presented here.
Thank you, Stefan. My name is Himke from Germany. I saw in your rasterized approach, my idea was, do you always use the same raster in all the cities? And did it conform to the European raster? I ask because in the Dike working group for the MSFD, we always also discuss a rasterized approach for the marine areas. And if you use a raster that is compatible to the European raster, I have in my mind, then you can already get some rasterized informations that are already available. Are you going this way, perhaps?
Yes, definitely. So the raster specification is the Inspire raster specification we are using. For population distribution, the basic information that is currently available Europe-wide is at 1 square kilometer grid cell size, which is a bit coarse in an urban environment to run this kind of analysis. So what we've done, and what is also explained in one of the publications referenced here, is to downscale the population figures, to estimate the population figure at the level of the building block as defined in the Copernicus Urban Atlas. It combines auxiliary data on land use from Copernicus, on building locations whenever available, but the input data, it's the Inspire grid definition, definitely, yes.
Yes, one more question, Marianne.
Thank you. First, I like a lot your live background. That is very much fitting to the subject of your presentation. I saw the trains and the buses going. My question is, were you actually already able to make use of some harvested Inspire data from the member states?
Yes, especially on buildings and their use characteristics and building height, because, well, there's a bit more to this than what I was able to explain, and especially when it comes to estimate workplace-based employment. There, the scale of the input data is a bit more coarse, so we need better auxiliary information to ensure a decent level of quality of the employment estimates by building block, and their building units and their height and their functions are of great help and are essential in order to ensure this. So we've used this especially for the Netherlands, for example, for France and a few others.
Hi. I'm going to talk about how in the Horizon 2020 project Eco Potential we implemented Inspire EF in order to provide standardized interoperable information. Can you just give me a quick show of hands if you are familiar with the Inspire application scheme, Inspire EF? So it's for environmental monitoring facilities. Okay. In that case, I have to be honest, I may have misjudged the audience, and I might have a presentation that's a bit technical, so I might skip 1 or 2 slides and maybe instead, if that's okay, do a live demo of our service, if we have internet connection, all of that.
Do we have Valantis in the room? No, I think that gives us some more options.
Okay,
Go ahead.
Great. So maybe let me just start by introducing the problems that we have in ecological research in general. We already heard a couple of presentations already during the Inspire conference, especially today, that concerned how crucial information about the changing environment is. However, one of the aspects that kind of gets neglected is the fact that it's not just important to have the data, but also to have the context information of data. So maybe just let me give you an example. So if you take a forest, for instance, like the one that I have coincidentally on my t-shirt right now, if you can see that, and you have a number of researchers and scientists that do research on forests, and they measure, all of the trees and the composition of the vegetation, and they monitor all of that, and they write it down and do proper science. At some point, you might realize that it's not enough to just have the monitoring of the forest itself, but there's a number of other components that you have to take into account. So a forest is not just influenced by the climate, it's also influenced by singular events. So if you take climate and weather, you have extreme events, you have storms that might damage the forest, for instance. You have the soil that also plays into account, meaning different soil types affect how a forest is growing. You also have vegetation, you also have animals. For instance, deers have the tendency to actually eat plants, which may hamper forest rejuvenation. And you also have bark beetle infestations, which massively affects forests. So there are actually a lot of things that you have to take into account when you're doing ecological research. And on top of all those like biotic things and abiotic things, you also have to take in the methodology. So how are you measuring, when are you measuring, what's the sensor that you use, where do you put the sensor? So there's a lot of things you have to take into account when you're doing research and when you store the data. And what happens, because I'm a data manager, is that on a regular basis, ecologists come to my office and they say, hey, Chris, I have this data set about some research that I did, and there are a number of things that I need to put in there just to show people that want to work with that research, that explains the data, that puts the data into context. Now, how do I put beetle infestation in the metadata so that people can understand it? And my usual answer is, well, to be perfectly honest, I'm not quite sure. I don't have the answer. I only have parts of the answer. So my presentation is going to be about my parts of the answer and how Inspire is one of them. So what we did is a piece to solving the puzzle is dimes.org. So that's a service that we developed, and we started developing that a couple of years ago. It's basically a site registry. It's more than just a site registry. So if you research sites that carry out all forms of ecological research, like forest ecology, and you can describe your research site. You describe the infrastructure that you have. You describe the ecosystem type. You describe the soil type. You describe the entire context information that I already explained to you before. And basically, you reference the data that you have, you reference to the site that you described on dimes.org, so that when people have a look at the research data, they get the link to the context information. Now, why am I explaining this to you? It's because on dimes.org, we implemented Inspire EF. I was a little too fast there, so that was my introductory paragraph about what Dimes does, but I already covered most of it. So dimes.org allows you to have access to a registry of research sites in a standardized manner. That includes all kinds of information entities, so I already explained the site to you. we also obviously have the data and datasets in terms of the metadata about the data. So you have a time series, you have the metadata about the time series, and they are connected to a number of data collection activities that we call data products that are somehow associated with the actual research infrastructure. On DIMES.org, we support a number of metadata formats. The one most crucial right now, as I'm explaining this to you, is InspireEF. So what does InspireEF do? So it's another piece to solving the puzzle that I already explained to you. InspireEF is an application, a schema that allows you to actually connect context information and actual time series data. So you get information about observation location. You can describe what a research plot looks like. So what your research plot about the forest looks like. What are special characteristics. You can also describe the personnel that's involved. You can put the actual data sets in there. You can link to that. You also can describe the infrastructure that was used to measure, meaning the sensors. And also you can reference to a number of projects and networks that the research is actually connected to. So on the right-hand side, you see the architecture, the information design that was used to implement it. And since just a couple of you raised their hands, I'm going to just briefly skip over this. This actually explains how we mapped our information design to InspireEF, but I mean, that was probably a bit too much for you. So implementations of InspireEF that were designed and worked that I'm at least familiar of are the EDI-EMF editor. So that's an editor that allows to create actual EF records. If you follow the links that are in the presentations, you might do that afterward. You can actually visit live demos or get the code or both of it. And on the right-hand side, you see a screenshot of the live demo that I'm spontaneously going to do for you. What another possible implementation of InspireEF is, since it's allowing to provide interoperable information about research sites and the data that is gathered at those research sites, you can actually use that to fetch information from different catalogs, research catalogs, and the data they have, and kind of create a meta catalog that accesses them, and in a standardized manner provide through one single access point multiple catalogs. So you have one access point that redirects you to different information entities about sites and the information and the data that they collected. So maybe I just do the live demo right away and then provide you with my conclusions. Okay, maybe just let me reload that. So that's actually the production version of an EF viewer that we wrote. What you see on there is everything that we have on DIMES.org. So every single green dot that you see right now is a research site somewhere on this planet, predominantly in Europe, because EcoPotential is a European project. And if you click on any of those green dots, like this one, for instance, you can go for more information about the sites. And what you actually get is a description of the site, the media that is monitored, online resources that are somehow connected to this research site, observing capabilities, meaning what is the research site actually researching, who are responsible parties, what it belongs to. And now what I'm going to do is I'm going to cheat a bit, because we have more than 1,000 records in our database. And if I just click on any random one, I might not find the proper ones. But there is this one in Austria. So that's a record that's a little more comprehensive, so it can showcase the capabilities of EF. So all the information that is currently pulled in is pulled in through an InspireEF record. And so what you get is a name, a persistent identifier, which is here, that always references to this specific research site. You get a description of the site, you have the media that's monitored. So this is a research site in the Austrian Alps. It's a mountain forest, so it's a terrestrial one. You get a number of online resources, and what you also get, if I can do that, is you get a number of data collection activities and observations. So you have, for instance, meteorology data that is associated with the research site. And when you click on that, it dynamically fetches the information that is associated with that research site. And you can go to the record or download the metadata. EF allows to also connect SOS services, if you're familiar with that service type. Unfortunately, in the records that we have, we don't have a single SOS record reference, so I can't showcase that. However, it also works with those data sets, and if you follow that link, you get redirected, and there you have the data set that's associated with the research site, and you actually can download it. And if you're interested in meteorology data of some research site in Upper Austria, you might do that. So that was the live demo. If you're interested in that, just go to dimes.org/map and you can play around with it if you're interested in ecological research that is happening in Europe. And now I'm going back to the presentation. Sorry.
Everybody who laughs now will become assistant here in a minute.
So my conclusion is that Inspire-EF is actually pretty decent. It can act as a standardized description of observation facilities, and not just the observation facilities, but also the associated data. So that's very useful. However, the thing about EF is that it's not very well implemented. It's not a very common standard right now. And the only thing that it truly defines is the syntactical interoperability, meaning you kind of have the skeleton, but you don't have the intestines. So whatever you put in an Inspire EF record is not standardized. So just because someone utilizes Inspire EF, it just guarantees that you can read it. It doesn't necessarily guarantee that you understand the context, the information that is in there. So basically, it's like a book, but maybe it's in a different language, so you can't read it. To me personally, the biggest problem is that, it's probably the case for most of the application schemas of Inspire, is that it's not a common standard yet. Implementations are rare. It's not exactly an easy standard to implement. It takes a lot of time. The documentation that is online is quite overwhelming. It's kind of the worst combination. You have a complex standard. It's hard to implement. Hardly anyone has implemented. There are no proper examples. You don't really have a guideline that takes your hand. So it took us quite a while to just get started and understand what's actually in the documents. And that leaves a number of open questions that we still haven't answered, like what's the best way to exchange EF files, and how to actually do the intelligent interoperability of Inspire services and their formats. Great. I hope you enjoyed it. So if you have any questions, please.
Thank you, Christoph. To combine this also with science and use these administrative standards, and you, at the end, you really described what is missing, right? Are there questions? Anybody has experience with EF? Yeah?
At least someone.
Well, we will see.
Yes, we are starting to put our monitoring stations for water height and water flow into the schema from Inspire. And what I'm asked when I start with this project is, what is the benefit? What should we put into Inspire beside the core model that anyone has any benefit and help out of this? Do you have any conclusion for me that you say, yes, I have an idea how I can make a good presentation of this under Inspire?
Yeah, well, that's the really difficult part, because I feel like with Inspire, like especially with this application scheme, like the groundwork has been laid, but since implementations are so rare, you can't really sell it. So, I mean, the biggest advantages of it are obviously the interoperability, and that you can exchange it and move it between different infrastructures. But if no infrastructure has implemented it, why even bother? I mean, the upside definitely is standardization, right? It's allowing you to move it around, and it's the only standard that I'm aware of about environmental monitoring facilities that exists like on this planet. But if no one has implemented it in the first place, why would you do it? So in a way, I feel like you probably have to force a few people to implement it, and then once you have a number of people that already run it, then it becomes more attractive to others.
I would want to talk to you after the conference. So
Sure, sure.
I think we had a presentation before that where we had a good example how important these informations about measurements, about the facilities are. If you want to combine data from different sources. And we kind of have the same problem, for example, in the field of species distribution, where obviously a map says, well, a species A or B is there or not there. But there are hundreds of ways you get to this finding that you see in the map, from a systematic search to somebody stumbled across this animal or whatever. You need to know what methods were behind this observation, and so it is impossible to interpret data, especially through several levels of information, without this information around it. So I think it's very, very important to kind of face this necessity to describe data like that.
That was more a comment, right? I mean,
It
a
was
reflection
more a
from your
comment, but
side.
I can say, yeah, it's true. I mean, it's basically what you're describing is my everyday life as like data management for ecology. So it's challenging. I mean, but you can only do it step by step, and we like kind of at the beginning did like the site-based approach, which is working well. But I mean, there's still like plenty of fields open, and I mean, with the increasing need to publish your data and make it understandable for others, you have to face it. I mean, you have to come up with solutions for it. The problem is there are so few at the moment that it's still a long way to go until you can, sustainably describe the data. It has to be, like in a way that it has to be.
Last question here.
It's actually, I would like to. I'm really like this model of environmental monitoring facility. It's quite complex to understand, but when you understand it, it can actually give you possibility to model environmental monitoring facility that can be opportunity ship until the station, which is a rain gauge, which is there. So not only on interoperability, but this interoperability really goes behind than just the same data that you are putting together, but actually it's a way how to standardize monitoring, not only the data. Okay.
Another comment, but yes, that's true. The one thing that I kind of omitted, because I didn't want to go into the details, is that the service that we built, dimes.org, did exactly that. And they did it already a bit earlier than what Inspire did. And it's just interesting to see that like two completely different separate groups came up with the same approach to provide context information for measurements. And I feel like that probably shows that it's not the worst of approaches to follow. If different people that have no connection at all just come up with the same solution or the similar solution.
Yeah. Yeah, thank you. I just want to add, I mean, of course, I can see that you struggle being an early implementer, right? But I'm quite sure we'll, in the next few years, see more of the environmental facilities being used. Also, we're discussing those in those implementation examples where we really move then from purely making metadata and data available as is to the interoperability aspects of the Annex 3. So I think in the coming years, we will see more of these examples. And I think just one thing I would like to say on behalf of the coordination team, there is the Inspire thematic cluster on which is a place where you can also put some questions, observations and so on. So the idea is through these clusters to use them also a little bit for community building. I think the JRC has been running some some session also related to the cluster, and there is also something you can look at the booth. So if you are in this area as somebody collecting experience freshly, I think it would be really good to share them. That is what I can thank you that you go this road, and I can encourage you to go on and try to get some exchange and networking through the clusters. I think that brings us to the last presentation.
Okay, thank you very much. I'm the lucky one to have the last presentation, but I'm very happy that you are all here still. So I hope you get some new information ideas based on this presentation. And this is a joint presentation by Kaisu Harju and Riitta Teiniranta from the Finnish Environment Institute, Syke. So let's go to the topic. The Finnish Environment Institute have a very clear strategy. They want to provide crucial information and innovative solutions for sustainable society, and very proactively respond to society's ever-changing information needs. So I think these are quite nice goals, but also very challenging goals. Syke has been one of the leading organizations opening data. They opened all the environmental data already 2008, and they are now actually celebrating 10 years of open data. And in Finland, Syke was one of the leading organizations. So, and after that, after Syke, many municipalities and national organizations started to understand the importance of open data. And there are many services that are open, and there are many datasets that are open. And Syke has used Spatial Monitor to analyze the usage since, I think, 2012 or something. And they know that the usage has been increasing every year. So there are facts about the number of users and number of requests that has been sent to the spatial web services, and also they have analyzed themselves their web maps. But what is the impact? So that is the question that actually arose in Syke, and then we thought last autumn, 2017, that let's start the pilot project to somehow assess the impact in a more concrete way that we are now actually, and somehow to connect these impact analyses to the strategy. And also Syke has a progress agreement with the Ministry of Environment, and there are more concrete goals for the operations. And the idea was to go through all the goals in that agreement, and then decide whether it's possible to set an indicator for that goal and get some information for the goal. And last November we started a project, and we used Spatial Impact. That's a process and service first to set the measurable indicators together with the customer, then collect the data automatically for those indicators, because you can also always do once the collection, but the key is to be able to do the assessment, impact assessment every year, for example, and get the data in the same way. So the data collection was done, and after that the impact was assessed so that we got values for the indicators. They are visualized in the dashboards. I will show you some examples. And then we analyzed the results of the indicators and the dashboards. So whether there are some recommendations, what should be changed, or that kind of things. And also now Syke, because we gathered the data from 2017 for the whole year. Now Syke has been using those indicators and thinking if they are relevant for them or should they have new indicators. So let's go now to the dashboards. This is the first one. Actually, the one goal in the agreement is that citizens participate more widely in observing and collecting data from environment. And then we set an indicator, citizens' activeness in providing observations. And Syke has actually a service or in the internet called LakeWiki, and it's a collaborative application between Syke and the citizens. And the citizens can provide observations to that. And there are different kind of themes like an ice condition. It's very important to know if you can walk on the ice or in spring when it's melting, and you can submit your own observation of that. If, for example, if you are fishing, you know what is the thickness of the ice. Also related to the algal situation, that was very, very bad this summer at the sea area nearby Finland, so citizens can submit observations. Then there is the surface water temperature. Of course, that's very interesting also to citizens and everyone. So there are tools, and there down left you can see that is for the winter observations. It was started October 2016. That's the light green color, and the more dark green color is from last year. The right one, the graphics, is number of users from 2016 and 17 related to the summertime observations. So we can see a huge increase in the amount of users in 2017. So it gives actually facts about how the citizens are, how active they are actually, and how they find this service. Then there are one goal that comprehensive information on built environment is available to authorities, companies, and citizens. And Syke has a service called Liiteri that gathers all the essential information related to built environment and land use planning. And now we can here see that there are, from different user groups, there are different amounts of users. So this blue color shows citizens and small companies, because this analysis is based on IP addresses, so we can't actually make a difference between small companies and citizens. But the orange color is local administration, and the red, yellow color is, for example, companies. So we can see the distribution of different user categories. And we used third-party databases to analyze these. I think that this is really, really interesting statistics. The goal is here that the key information user groups are use environmental information. So that's local authorities, national authorities, and companies, and of course citizens. And then we created an indicator that actually shows which user groups actively uses those web maps. The web maps are actually there on the top, and there the most popular web map is the Vesikartta. It's a water map, most used. Then in the middle there are the OData API, and on the bottom there are the spatial web services. And if we look at now the users, we find out that the national level administration is using the spatial web services. They have readiness and competence to use it in their activities. Whereas the companies are using the OData, data from the OData APIs. And of course, those web maps, they are very easy for citizens and small companies. So they are the main group of using those web maps. But of course, there are others. But this is very interesting. And also, Syke made a small survey in order to compare this. Is this reliable, the results? So what the companies say themselves they are using. So there is Kaisu Harju from Syke who can answer if you have any questions related to this. Then one important goal that is set to Syke is that they actually should help to decrease the vulnerability of cities in climate change. And of course, this flooding and flood risk is one of the important things, because in Finland, you know, there is the coastline is about 5,000 kilometers, and there are a lot of cities along the coast. So all those cities have the flood risk. And so the indicator we defined is that all municipalities that have flood risk areas use data from flood risks, because there is a very, very good service created by Syke and the Finnish Meteorological Institute about this flood risk. It provides real-time information, but also analysis of the risks. So what we got from our analysis was that there are 37 municipalities that have flood risk areas on the area, but only 11 we could get information that those 11 municipalities that are listed here, the Helsinki is the biggest one, are using the data. But here we didn't have access to all possible information, so there are some limitations in these statistics, and that has to be improved. But it's very valuable information, because if those are not using, why are they not using? Do you have to actually promote these services better? So what kind of recommendations and further actions we found out after the project? So one key thing is, of course, that you get all the information of the usage from web maps, data downloads, citizen submissions, and observations. So there were also something missing from the citizens' observation submissions. So it might be that there are more than that, you know. And also to study and understand why some web maps are very, very popular and the others not. Is it a natural reason, or is it so that the potential users don't find those web maps? And also, as I mentioned, the better communications of flood maps to those target municipalities. And of course, this was a pilot project, and I think they have internally now looked at those and discussed, are these indicators the best one, or should they change something, or are there other things that should be actually measured or assessed, in the coming years. Okay, but thank you.
Thank you, Jana. Very, very factual, nice presentation. I see we have still energy for questions. 2, 3, maybe.
Yeah, a short question. You used relative figures, that is very typical, but for a benchmarking, it would be nicer to have goal figures, kind of. It should be 100% should be a number of, I don't know how many administrations. Is there any concept that you have how to deal with such a benchmark?
Yeah, actually, you raised up a really good issue, because we only could set one target indicator. That means that we can set the target, but the others are kind of followed, because there were not such kind of targets set in the agreement between Syke and the ministry. But also, of course, Syke can set those targets as well. But that's then you actually can compare how the performing of the services are doing. Yeah.
Yeah, I think. Yeah.
As a governmental organization, are you allowed to use Google Analytics? Because in the Netherlands we are not allowed since a few years.
I just mentioned that, of course, we did this 2017, so the GDPR was not in action at that time, but that was, we took the notice that we didn't actually use, even in this project, the data, the IP address, the digits from the end of where. And also the Google Analytics data, it's managed by Syke. So, yeah, and they gave us the data, so we didn't have access to the data itself. But yeah.
Yeah, thank you. I think that's a very last question here for this session. I think I can. Is that your question? Oh, yes. So she was asking where to find the presentations. I'm pretty sure on the website of the conference all the presentations will be made available, because that's why they're asking to bring them to this special room there. And so you can be confident, because I saw also many of the colleagues, they provided a lot of links and so on. So I think that will be happening.
Yes.
And just a short comment to your presentation. I think, yes, you can always do better on this monitoring, but I think we have here a case where an institution really goes out and not only proudly presents figures on the web services and so on, but also is reflective and looks at the users and the improvements. I think this is excellent, and we need to see more of this, I find. But this, I think, concludes our afternoon session. I think it was a fantastic session. We had 5 excellent presentations. We used the time. We didn't miss a presentation, I think, even though it was interesting. Something with night and data, but anyway. So we had 5 great presentations, and thanks a lot to the presenters and to the audience, and I wish you a nice evening.